If you're lucky, if your data is very simple, you can just get one summary statistic. Oh, the average, that tells the whole story. Maybe not. You need the average and the standard deviation. Okay, all Gaussian data can now be described. To fully describe increasingly complex things, we need increasingly complex algorithms to describe them. But despite all that, it's pretty surprising how often a simple visualization really does tell the story of the data. Basic scatter plot or a histogram usually does the job for me. No one ever seems to want my upsell to make some fancy doodad visualization. And it's not that vanilla tastes best, but maybe data visualization is our big hope for how we understand machine learning and face our challenges with interpretability and explainable AI and all this sort of stuff. I've not been able to pin down the exact derivation, but as I recall, it's a picture's worth 1,000 words. Maybe the data visualization is the minimum description length for our eyeballs to best consume. Welcome to Data Skeptic Interpretability. This week on the show, I invited my old friend Enrico from the Data Stories podcast to join us for a primer and a bit of details on his research into the intersection of data visualization and interpretability. All that and more right after the break. It seems like there's an infinite amount of information uploaded to the internet every day. But it's hard to know what's accurate, factual, believable. That's why I love having the Great Courses Plus. They produce valuable, in-depth content that I trust. This streaming service offers thousands of objective, unbiased lectures from respected professionals who really know their stuff. The lectures range from topics like mental math skills to the history of the American presidents. And the best part is, with the Great Courses Plus, you can watch or listen anytime, anywhere. I guess I've got trust on my mind because I was watching some of the lectures from Fighting Misinformation, Digital Media Literacy. This series of 8 lectures covers the misinformation threat, what technology's role is in it, how it affects the brain, and a variety of other interesting takes on the topic. You can check out that course or hundreds of others by visiting thegreatcoursesplus.com/data. Best of all, they're offering my listeners an amazing deal. 3 months of unlimited access for just $30. That's $10 a month. You can't beat it. But to get that limited time offer, you must use our special URL. It's thegreatcoursesplus.com/data.
I am Enrico Bertini. I am an associate professor at New York University in New York City.
Well, Enrico, welcome to Data Skeptic. I'm guessing some listeners might recognize your voice from hearing you on the Data Stories podcast, proof that all of the data podcasts take place in the shared universe, kind of like the Marvel movies. In case you have some people who haven't listened, tell us a little bit about Data Stories.
First of all, thanks for having me on the show. It's great to be, for once, on the other side of the virtual glass. So Data Stories is, I would say, a data podcast with a very strong focus on data visualization and design in general, even though it doesn't have to be always data visualization. It's a podcast that I host together with Moritz Stefaner, who is a data visualization designer. We've been doing this thing for quite some time now.
Yeah, I'm always looking forward to new episodes. It's a really good show. One of the first times we connected, I had released a kind of provocative episode. I believe it was called Death to the Word Cloud or something like this. And I was unaware of some of the work you were doing. Why don't we pick it up there? What are your thoughts on word clouds?
We could go on forever with word clouds, right? Word clouds is one of those visualizations with interesting trajectories, right? It just happens to be used by a lot of people. And then there are some quote unquote experts or academics that come and say, oh, word clouds are really bad. And then, but on the other hand, everybody uses it. Very often in visualization, you have this dichotomy where a lot of people use a certain visualization technique, but then there are the experts who actually criticize it, and there's a clash between these two things. Some time ago, we've been doing research in this space to try to figure out whether word clouds work or not. We ran some experiments to actually see what word clouds are good for, and it turns out they're not as bad as I thought.
Yeah, I think some of those details come from the execution. One of the things I enjoyed about that one was you guys sort of follow the tradition of a lot of really good empirical work that's out there, like way back to Cleveland and McGill, people who are studying basically how much can a person learn and can they learn the correct thing looking at a graph or any visualization, word clouds or otherwise. How do you go about measuring something like that?
I think typically what we do in visualization research, we identify what I call a design space for a visualization problem. So in that case, even before you decide to visualize something with a word cloud, you take a step back and ask yourself, what is the actual problem that we're trying to solve with this visualization? And then you try to answer design space of possible visualizations to solve the same problem. That's one step. Another step is what are the actual tasks that people are supposed to execute with such visualizations to solve this problem. And then what you typically do, you run an experiment with controlled study where you show people different versions of the visualizations and you measure some performance metrics and trying to figure out which solution in this space works best. So we try to configure it as a controlled experiment, typically drawing from experimental design from psychology or cognitive psychology and human computer interaction.
And do you have any takeaways? If someone is committed to making a word cloud, how can they make it most clear for their audience?
Yeah, I think what is really important with word clouds and in general for visualizations, I think it's never black or white. So you can say pie charts are bad. Pie charts are not always bad. It depends on what kind of pie chart you design and how you apply it to real problems. And I think it's the same with word clouds. So do you have a super flashy word clouds with colors that don't make any sense and the positioning doesn't make any sense, weird fonts, and there are so many parameters you can play with, right? At least to me, it doesn't make sense. Word clouds are always bad or they're always good. There is a lot of free parameters you can play with that can make a word cloud actually good or bad. So I think this is partly also what we find in our experiments. We find that it depends how you actually design your word cloud. I think another issue there is that the same design can be good for certain tasks and not that good for other tasks. So if you want to say a classic task in to evaluate visualization is to see how accurately people can extract quantitative information from a graphical representation. So classic example is if I map a quantity to the length of two bars or the area of two circles, which one gives you the best estimate, right? If you show these quantities to people, people tend to estimate the values better with bars rather than areas of circles. And of course, you can expect the same to happen with word clouds. Do people create better estimates with the size of a font or the size of a bar? And it turns out that bars are much better. But that's not the only thing that you do with a word cloud. So for instance, if I'm searching for a specific term, a word cloud is pretty good. It's better than using bars because when you use bars, then you have to decide where to place the labels. And the labels for a word cloud are really important. And in a word cloud, the most important terms are actually bigger, so they're easier to find and to perceive, which you can do with a bar chart. If you experiment with the task of finding an actual term, you will see that a word cloud is much better.
So we've kicked off a little mini series on Data Skeptic. I guess we'll call it a season. It's going to go for a couple months, all focused on model interpretability. It was important to me that I get into some visualization discussions early on because it seems like that ought to be one, if not the primary key for helping bring interpretability to people. Can you share some of your thoughts on how visualization can help explain machine learning to people?
Well, I think that's a super interesting space, and it's actually one of my research focuses right now. The interesting aspect of interpretability is that something that has to happen from the human side. Of course, there is an algorithmic and computational side of it, but ultimately, interpretability is something that humans do. So sooner or later, in your interpretability pipeline, or whatever you want to call it, there will be something that you have to show to an end user, to a human. And every time you have to show information to someone, visualization plays a role because there are visual representations that work better than others. That's the main link, the main use of visualization in interpretability. There's so much going on right now. I think virtually in many areas of computer science, people are trying to solve problems in interpretability. So you have, it's not only people in visualization or human computer interaction, you have people from machine learning, from databases, and from many other areas of computer science. The specific problems in visualization, I would say there are many. One specific problem is that when you want to get a sense of what the model is doing in its I would say typically people say globally. So what are the main set of decisions that the model is making, right? Rather than looking at individual decisions. Now you have to represent visually either a very complex structure or a very complex decision space. And you have to provide means for the end user to navigate through this space. And this is typically what visualization researchers are good at. They're really good at devising visual representations and interactive tools to explore these visual representations. And I would say that's one of the main interesting directions for visualization in this space. That said, there is another one that is really, really hot right now that is more for people who are interested in looking inside neural networks or complex architectures. So there are several researchers in visualization who are focusing their attention on how do I visualize neural networks in a way that researchers can understand how a neural network is doing what it's doing and how to actually optimize it, improve it, and debug it. So I would say these are two really exciting directions for visualization in this space.
Following up on the idea about knowing what a deep neural network is doing, I think a cynical person could say, well, it's doing tensor algebra, that we understand it, but it's kind of like explaining why World War II happened in terms of the superposition of electrons. It's just not the right domain. What can some of those tools look like? Am I going to have something that's probing the network and showing me a reduced version of it? Or what can someone expect if they want to have some peek inside the black box a little bit?
So let me first state that that's not my specific area of expertise. I'm not applying visualization to neural network architectures, but I am familiar with other researchers' work. I would say that it doesn't have to be necessarily a visualization of the actual full architecture of a network. So typically what visualization researchers do is to abstract away the actual architecture. That's an important piece of information there. I think recently what I've seen that is really interesting is that in these abstractions, researchers are trying to help machine learning researchers see what is it that individual parts of the network are quote unquote thinking. So say that this part of the network is trying to do this activity or this other activity. So by doing that, they actually try to spot issues with the network or the way the network is making decisions in different layers, right? It comes to mind a recent work that I've seen published at this last year. It's hard to describe without showing you what it is about, but I'll try. So there's an abstraction over the layers of the network, and you can hover with your mouse over the individual nodes, and you can actually get a preview of what part of the images are captured by that node of the network. And by doing that, you can also identify some issues, some mistakes that the network makes. And this is where you may want to intervene to fix it. That's what some people have been doing in this space. So it can be done. I have seen visualization work done with, say, convolutional neural networks for images, but there is also a lot of work going on for a more natural language processing type of work. There's a lot going on in this space.
I can imagine where one approach could be to develop new interpretability methodologies to complement the algorithmic methodologies. So, as you were saying, people have done things for deep learning. Maybe there's a support vector machine interpreter model out there somewhere, but then we're going to need as many approaches as we have algorithms, unless we look at things like surrogate decision trees, for example. Could you give me a little background on what that is and how that could solve a problem like this?
This is where we are doing actually some of our research, so I can probably say more. I think the basic idea of surrogate decision tree or surrogate model in general, the idea is to simulate. So say if you have black box model that has been developed and either you don't have access to it or you do have access to it, but it's a complex model like a neural network or a boosted tree or anything that is too complex to be directly interpretable, what you do is that you try to train an additional model that tries to simulate as accurately as possible the original model, but is more interpretable. And in this space, typically decision trees have been used a lot because decision trees are considered one of the most interpretable methods. So basically, it's what I just said. You train an additional model based on the original model. And one way to do that is to use the output generated by the black box as labels to train your more interpretable model. So say, instead of training your decision tree on the original data, you train your decision tree on the labels that are generated by the original model. That's the basic idea. And of course, there are a number of problems there. So one of which is, how do you actually visualize the tree once you built it? Because it may end up being really, really complex.
There's also an interesting comparison maybe to be made between the surrogate model and the real model. I would imagine the surrogate model isn't 100% the real model. I'm not even sure what I'm measuring there, but we want to get as close as we can. Do we get any theoretical guarantees or boundaries or anything like that come along through the techniques that are available?
Not that I'm aware of. That's an open issue, right? Because what people say is like, if you can actually get the same accuracy as the original model, why don't you just train a more interpretable model, right? It's an interesting, catch-22 there. I think the terminology that is typically used in this space is the idea that you can measure fidelity for the surrogate model. So the surrogate model may have a certain amount of fidelity in terms of how good it is at simulating the original model. I think an interesting thing to say, though, that also speaks for how to actually use these surrogate models in practice and when and how they can be useful. I think one shouldn't be too concerned with the overall accuracy of the surrogate, which is of course important, but even more important is when you look at the individual path of the tree or rules that you can extract from the tree, then you may have paths that are very, very accurate with very, very high fidelity, and because of that, they're really, really useful. So in a way, what I'm saying is that the tree or the set of rules that you extract from the trees can have very different levels of fidelity, and when they have high fidelity, they are really, really useful. I think in general, similarly to what you would do when you are investigating any model, the overall accuracy or fidelity in this case is really important. But even more important is that there are segments of the data where the model may be more or less accurate, basically.
Seems like maybe there's this inherent trade-off between accuracy and interpretability. Obviously, that's not the same trade-off as like the bias variance trade-off, which is very formal and theoretical. Do you think we'll ever get some sort of parameter where we can say the degree to which we're willing to compromise?
I don't know. I think there are people out there who've been pushing back in this idea that there is always a trade-off between accuracy and interpretability. I've seen people writing papers that basically explain that this is not necessarily always the case. I don't know exactly what the right answer is. I think there are a lot of people right now in machine learning who are trying to come up with new methods that are as accurate as other methods, but much, much more interpretable. And I suspect there's going to be many more solutions in this space. So that's not exactly the kind of research that I do. My focus is more in visualization, but I know there are a lot of researchers out there who are trying to create new algorithms to create models that are as accurate as the most complex models, but at the same time, way more interpretable.
When you have something like the surrogate decision tree, you could show those to someone with domain expertise. Maybe they don't know ML, but they know the space. What's it like when a person in that position gets the interpretable tree? How do they kind of digest it?
So let me say something before I describe how this looks like. What I think is really important in this space is that we shouldn't focus exclusively on creating solutions and visualizations for data scientists, whose focus is mostly on improving model performance and debugging, but also on creating interfaces that we can use to explain things to domain experts or collaborators. As you said, they may not actually understand machine learning very well. Having tools and methods that makes it easy or easier to show what a model does to a domain expert is a really, really important goal. That said, so what happens when you do that? We have some experience from our side. So some of the work that we've done in the past is in collaboration with some of my colleagues at the NYU Langone School of Medicine. Some of our collaborators are physicians who understand the data very well, but they may not understand machine learning very well. So when you show this information to them, the way they approach it typically is whether what they see makes sense to them or not. And it's really interesting because typically what happens, at least in my experience, is like there are things that are correct but obvious, right? So let's say that a physician scans a set of rules, right? And the first one is like, oh, yeah, that's pretty much expected, not particularly interesting, right? Second second one, oh yeah, that's also pretty obvious. But sooner or later, they stumble into something that is not obvious. And now, when something is not obvious, there are only two cases basically. Either the model is showing to you is wrong, or this thing is actually a real pattern in the data that captures something that happens in reality, but doesn't match very well with the existing knowledge or mental model of the physician in this case. I think this is where things start getting really, really interesting, because when you expose, say, a physician to a model of their reality, they may actually learn new things. So in our case, in one of the sessions that we had with our physician, I actually saw him scanning this list and then coming up to a rule and saying, this actually shouldn't happen in the hospital. It was data coming from the emergency room specifically. And he said, this is not supposed to happen. And he kind of like laughed. In my experience, is a general pattern. And it also exposes us to a bigger challenge. The challenge is that not all patterns are equally interesting. They may all be accurate, but not interesting. And my experience with domain experts is that most things that algorithms capture are pretty obvious. But obvious is good for confirmation, but it's not good for generating new knowledge. So I think the little nuggets that are really interesting there are things that models capture that somewhat break the mental model of the end user or the expert. And this is where you have to figure out whether it's a spurious pattern that the model captured or it's a new discovery for the end user. I think there is a lot to do in this space, and I feel like we don't understand it very well yet. At least this is a space that makes me really excited.
Following up on trees and how they're sort of perceived as being these interpretable structures. And I think they are intuitively, but also there's two good back-to-back slides. I've seen this in many presentations, including my own, where you show the easy one, how you get to miles per gallon, and then you show the tree with 1,000 nodes in it. How do we solve that problem?
That's an excellent question. It's part of the work that we are doing. So that's something that drives me mad, because we have this weird attitude where, so first of all, the way we talk about interpretability is either a model is interpretable or not interpretable. And I think that's not a good attitude. There are way, way more shades of gray. So decision trees, as you just said, are probably the most interpretable kind of model out there, right? As soon as you go past a few tens of nodes and 3 or 4 layers, right? It's a mess. You don't know exactly how to extract information out of it. On surface, it looks like they're interpretable, but in reality, they can get very complex very soon. As soon as you work with complex data, you will see that you get very complex trees. So how do you do that? I think this is where, of course, visualization plays some role. But again, with visualization, you still need to visualize hundreds, if not thousands of objects. So the next thing you can do is to use interaction to filter out things according to what is it that you're looking for. And this is partly what we are doing. Another thing we've been playing with is this idea that even if you're using a tree and you extract and you visualize information from the tree, it's not necessarily true that the best visual representation is the tree itself or only the tree itself. So what we've been playing with is this idea that you can have a tree structure, but then visualize the tree not necessarily as a nodeling diagram representation, but other visual representations. And that's partly what we are doing right now.
I had a chance to get, I don't know if it was a private preview, but it felt pretty exclusive and fun to me in that regard of some of the software you were developing. And I don't know if that's directly connected or just sort of in the same neighborhood as the Visus system, which I've been reading about from the paper I'll have in the show notes. But I'd love to hear just some directions on how you go about building some of these tools and what facilities you want to make available to users with these things.
I see two main goals here. One is to help, say, people like you who do a lot of work in data science to make it easier, first of all, to understand where errors are, right? Where the errors come from, and hopefully even how to fix them. As I said, that's only one side of the coin. The other side of the coin is if you're talking with a customer or you're collaborating with a domain expert, you want to have an easy way to show to your customers or collaborators what the model does in a way that is not too complex. And that's basically what we're trying to do with these visual interfaces and tools. Make it easier for people like you to quickly gather information that you can show to end users so that they can give you feedback and can also hopefully gain some trust in the work that you are doing. Right now, I see two main approaches to do that. At least that's what we've been working on. One approach is basically what we've been talking about. Say you create a more interpretable structure on top of your model and you visualize it in a way that it's easy to understand the decision space of the model. So it could be trees, it could be rules, anything that is as easy as that. On the other hand, another approach for people is to work on individual instances, right? People are naturally good at judging whether an individual instance is the prediction that the model makes on an individual instance is correct or not, right? I've been talking with a lot of data scientists, and it looks like very often they work at this basic level of individual instances. Even when you work with individual instances, you still have the problem of deciding which instances do I actually show to the person I want to talk to, I want to collaborate with. And I think this is another challenge. So how do you slice and dice your data in a way that you can identify subspaces, basically, where interesting data points lie? And I think that's another interesting challenge there. Rather than working on the space of decisions or rules, more like figuring out how do I find, let's say, subpopulations where interesting things are happening. And when I say interesting, it can be where things are going really, really well. So it can be confirmatory that people should be, your customers or experts should actually trust the model, because when for these specific cases that they really care about, it's doing exactly what is expected, right? As well as cases where, oh, this is maybe not working that well, and this is what is happening, and maybe you can investigate it further. So I think these are two broad classes of methods that I see happening right now.
The instance ones we haven't touched on as much. Maybe they're slightly outside of just pure visualization, but are you aware of techniques or approaches by which people could scan a data set and say, hey, if you're going to look at 10 examples, these are the 10 that seem to best prescribe how the model works?
Yeah, there are quite a few right now. Off the top of my head, there is a recent paper. I'm blanking on the authors, but I think the tool and the paper is called Slice Finder. It's been published in one of the major data mining or databases conferences. I can send you the link and can probably put it in the show notes. And what Slice Finder does is a really neat algorithm. It's basically looking for data cubes where interesting things are happening, where there is a high error rate or something like that. So for instance, say, I think in the paper they use a classic data set or a demographic data set where you have to predict whether the salary of a person is going to be above or below 50K, right? So what Slice Finder is doing is to find, say, oh, if you have a gender is male and age is below 30 and the person is living in this region, then the model is making a lot of mistakes, way more mistakes than usual. So it's basically trying to automatically find data slices where interesting things are happening. So you may have models that have a very high overall accuracy, but slices where the model performance goes down very quickly. You can use these slices as flags for things that you may want to check. And I think that's a really, really interesting approach. I think a similar approach has been used by some other researchers for work on bias and fairness, which is another area that is super hot right now, and of course connected with interpretability. So there's another couple of papers published last year at IEEE Viz conference. I think one is called FairViz and the other one is called FairSight, which use somewhat similar approaches to basically automatically suggest data slices where bias may happen. And of course, you always need user involvement in the end because you want to check. But there is an algorithm and a visualization that basically tells you, oh, you may want to take a look at that because here I can see that the model performance is going down and down a lot with respect to overall performance. I think, as you can imagine, this is also good for bias detection because if the features involved are, say, protected features, or you want to make sure that there are protected segments of the population there, well, then it's an interesting flag and you may want to check what is going on there.
In building out some of these tools, I'm curious to hear where they are in the progression. Obviously, they begin as research endeavors. Maybe there's a corporate sponsor, something like that. Are your systems something that people can work on today, or are they headed in that direction? Basically, what's the roadmap ahead?
Yeah, I think that's one of the biggest problems for research products, I would say. I think the way we typically operate in research is that we develop software that is needed basically to put the idea out there, but it's rarely software that is, say, very stable, very usable, that people can easily install and try out in their infrastructure. I think that's a big problem for research in general. It's not that easy to adopt the tools that have been developed in a lab. On the other hand, this is due to the fact that the research labs, especially in universities, can't really afford having a team of software engineers that do everything, say, high end and very, very neat, right? I would say the last mile is the hardest part. And you have to imagine that most of these systems are developed by PhD students who are very busy with their research. They just can't afford spending, say, a whole year, if not more, just making their software easier to install and use by other people. Of course, there is a lot of value in doing that, but there is a trade-off by spending a lot of time doing that and working on the next paper or the next research idea, which is really what gets rewarded in the system. We could talk for hours whether that's a good system or not. This is how things work in academia and where the biggest challenge is.
Makes sense. So maybe we would say that some of these systems are there to inspire the next generation. Would that be one way to look at it?
Absolutely. And let me add that I think for visualization, the problem is a little bigger because in machine learning or related areas, I would say it's easier to come up, say, with a Python library, and then you download the library, you install it in Jupyter Notebook, and you can give it a try, at least, right? It may not be the neatest code, it may not be super robust, but at least you can try it out. And you can also fix it if you want, right? You just create a branch and you may fix a problem that you find. But with visualization, things tend to be way, way, way harder. The technology itself tends to be much more complicated. So it's not just installing a library and giving it a try. So I think that's a real bottleneck for visualization type of work.
Definitely. Sort of day-to-day visualization. If I were going to develop something for my blog, I have to consider the audience is the whole world, and I have to take their, visual literacy and their numeric literacy into account. And sometimes simple, even plain vanilla charts like a bar chart or a scatter plot tell the whole story, even if they don't have a lot of sex appeal in designing the visualization. But when it comes to people who are going to potentially look at the outputs of the tools like you've been describing, that person, they need to know some machine learning so we can make bigger assumptions about their background and in how they read charts and things like that. Are you able to leverage that presumed higher step in visual literacy to make your tools more powerful or more robust in some way?
I think in principle, yes, even though my experience over the years is that maybe somewhat unsurprisingly, for the very large majority of cases, the most basic charts work really, really, really well. So kind of like one of my personal mantra is that try a bar chart first and then see where the limits are for that, right? I often have this joke with one of my friend researchers, like bar chart it first, right? And then if it doesn't work, you may want to do fancier things. And I think we have a tendency in visualization to really like fancy things. And I'm not against fancy things if they are effective. And beauty plays a role because people may actually like things better. It's more enjoyable as long as these things are effective, right? And interestingly, I mean, I've been working in this space for many years now. It's somewhat uncommon that you really need to come up with a completely new visual representation or strategy for a given problem. That said, what I think is harder is to use the most basic charts well. There is a lot of misuse. And also how to put these things together in an interface, right? Okay, we're not talking about a single chart. We're talking about interactive tools where you have to integrate more than one element at a time. So technically speaking, in visualization, we call these multiple linked views, which means you have an interface with more than one visualization. And typically when you interact with one view, something is happening in the other view. I think normally people describe these like dashboards, but they can be complex interfaces, complex objects. And what I notice is that what is much harder is to put all of these things together in a way that is not too complex and at the same time it's intuitive and works well. So I think in reality what happens is that most basic charts work really, really well in most cases, but using them well is not easy. So I think this is where the challenge is.
So tell me a little bit more about what your lab is up to and what's coming next for you.
One of the main focuses of the lab right now is on machine learning interpretability, and we are really excited about that. But I would say there are two other main directions that we follow. I think traditionally we've been doing a lot of experimental work, similar to what I described at the beginning on word clouds. So the type of work that we really like to do is experimental work to advance our knowledge on what works and what doesn't work in visualization. So we always have experiments. Some of my students are running experiments to basically figure out new guidelines for visualization designers. That's research that is always ongoing in our lab. And then there is another area that is more, it's hard to describe, but I would describe as general data sense making kind of work. I am really, really interested on how people think with data and data visualization, and how can we help people solve complex problems with visual analytics in general. So just to give you a very quick example, we've been working for a while with cybercrime and working with investigators, and they have messy data with, say, some of it is documents, some of it is time series, some of it is networks. It's all at once, and they have to make decisions. They have to figure out how, say, a group of criminals are operating. It's very complex, and visualization can play a role there. And I'm really interested in understanding, how do we help people solve these very complex problems with visual analytics tools.
Excellent. Well, I'm going to have links to things we discussed in the show notes, as well as a link to data stories so people can hear more from you. And do you want to give out a Twitter link or anything like that as well?
Yes, my Twitter handle is, if you search for Enrico Bertini, you're going to find it. And so you can find me there. I also have a website. It's just enrico.bertini.io. And this is where you find information about our latest research. And of course, you should go to Data Stories. That's datastory.es. If you've never listened to our show, please do. It's fun.
Yeah, one of my favorites for sure. Well, Enrico, this was great. I always love catching up. Thanks for coming on. Thanks for listening to Data Skeptic Interpretability. Our theme song is Number 5 by Big D and the Kids Table. Claudio Armbruster is our associate producer. Vanessa Burciaga is our guest coordinator. I've been your host, Kyle Polich. See you guys next time.